Color addition. Color perception, like sound perception, is a complex subject involving the discipline of psychology, physiology, biology, chemistry, and physics. When you look at an object and perceive a distinct color, you are not necessarily seeing a single frequency of light. Consider, for instance, that you are looking at a shirt and it appears purple to your eye. In such an instance, there may be several frequencies of light striking your eye with varying degrees of intensity. Yet your brain system interprets these frequencies that strike your eye, and shirt is decoding your brain as being purple. Primary light of color. The subject of color perception can be simplified if we think in terms of primary colors of light. We have already learned that white is not a color at all, but rather the presence of all frequencies of visible light. When we speak of white light, we are referring to Roy G. Biv, the presence of the entire spectrum of visible light. But combining the range of frequency in visible light spectrum is not the only means of producing white light. White light can also be produced by combining only 3 distinct frequencies of light, provided that they are widely separated on the visible spectrum. Any 3 colors or frequency of light that produces white light, when combined with the correct intensities, are called primary colors of light. There are a variety of sets of primary colors. The most common set of primary colors is red, green, and blue. When red, green, and blue light are mixed or added together with a proper intensity, white light is obtained. This is often represented by the equation R plus G plus B equals W. In fact, the mixing together or addition of 2 or 3 of the primary colors of light with varying degrees of intensity can produce a wide range of other colors. For this reason, many television sets and computer monitors produce a range of colors in monitors used by the use of red, green, and blue light-emitting phosphors. The addition of the primary colors of light can be demonstrated by using a little box. The light box illuminates a screen with the 3 primary colors, red, green, and blue. The lights are often the shape of a circle. The results of the addition by adding 2 primary colors of light is easily seen by viewing the overlap of the 2 or more circles of the primary light. The different combinations of colors produced by red, green, and blue are shown in the graphic below. Caution: because of the way that different color monitors and different web browsers render the colors of the computer monitor, there may be a slight variation from the intended colors. Color addition rules. These demonstrate with the color box that illustrate that red light and green light add together to produce yellow light. Red light and blue light add together to produce magenta light. Green light and blue light together produce cyan light. And finally, red light and green light and blue light added together produce white light. This is sometimes demonstrated by the following color equations and graphic. R plus G equals W, R plus B equals M, G plus B equals C. Yellow, magenta, and cyan are sometimes referred to as secondary colors of light. Since they can be produced by the addition of equal quantities of 2 primary colors of light, the addition of these 3 primary colors of light with a varying degree of intensity will result in countless other colors that we are familiar or unfamiliar with. Investigate. On this page, we've discussed adding red, green, and blue light in equal intensities. What happens if they are added in unequal intensities? For instance, suppose you are on a stage lighting team for your school theater. Your task is to control the red, green, and blue stage lights to produce various color effects for the upcoming show. Use the addition color widget below to adjust the strength of the red, green, and blue lights relative to a full strength. A 1.0 indicates that the light is on full strength, and a 0.00 means the light is off. All numbers should range from 0 to 1. Once adjusted, click Mix 'em Up button to find the result of the mixing red, green, and blue components of various strengths. Complementary colors. Any two colors of light, when mixed together in equal intensities, produce white, are said to be complementary colors of each other. The complementary color of red light is cyan. This is reasonable since cyan light is equivalent to the combination of blue and green. The blue and green light, when added to red light, will produce white light. Thus, red light and cyan light, which is equivalent to blue plus green light, represents a pair of complementary colors of light, then added together to produce a white light. This is illustrated in the equation below. R plus C equals R plus B plus G equals white. Red plus cyan equals red plus blue plus green equals cyan. Each primary color of light has a secondary color of light as its complement. The three pairs of complementary colors are listed below. The graphic at the right is extremely helpful in identifying complementary colors. Complementary colors are always located directly across from each other on the graphic. Note that cyan is located across from red, magenta is across from green, and yellow is across from blue. Complementary colors of light. Red and cyan, green and magenta, blue and yellow. Magenta and green, blue and yellow, red and cyan. The production of various colors of light by mixing the three primary colors of light is known as color addition. The color addition principles discussed on this page can be used to make predictions of the colors that would result when different colors of light are mixed. In the next part of Lesson 2, we will learn how to use the principles of light addition to determine why different objects look specific colors when illuminated with various colors of light. We would like to suggest sometimes it isn't just enough to read about it, you have to interact with it. And that's exactly what you do when you use one of the new physics classrooms interactive. We would like to suggest that you combine the reading of this page with the use of the RGB color addition interactive. The interactive is found in the Physics Interactive section on your webpage and allows the learner to adjust the intensity of red, green, and blue spotlights shining upon a white surface to observe their appearance. Explore the results of mixing RGB light in equal or unequal intensities.